All right, we're going to cover how to do different concentration, molarity types of problems today. Molarity, you can get the picture of the notes from up here about just the background, but I'm just going to focus on the math for this one. Molarity, which is the concentration of a solution, is equal to the moles of solute that you dissolve divided by the liters of solution. Okay, so that's your basic equation. We're going to give you a triangle equation that helps you with your algebra. So we know molarity, that capital M, underline means molarity, is equal to the moles over liters. So whenever you're using this triangle equation, you cover up the variable you're looking for, and that helps you set up your algebra correctly. So if you're looking for molarity, if you're solving for molarity, you're going to do moles divided by liters. If you're solving for liters, you're going to do moles divided by molarity. If you're solving for mole, cover up mole, you have molarity next to liters. That means you're going to multiply those two to find moles. Okay. Okay. Things to remember: the volume has to be in liters. So if you have to convert milliliters to liters, you have to do that sometimes. And then sometimes if you're given grams, you have to convert that to moles. Or vice versa, where maybe the problem gave you the moles, but it's asking for grams, so you'd have to use a T-chart just like this way. Okay, so let's do a sample problem. 3.4 moles of sodium hydroxide is dissolved and added into 45 liters of water. So what's the strength? What's the molarity? So we're going to use the triangle equation and plug in our variables. We're looking for molarity, so we know we're going to leave that as our variable. They gave us moles, 3.4 mole, and liters of water. So that goes on the bottom here, 45 liters. Okay, so I see 3.4 over 45, which means I'm going to divide. So 3.4 divided by 45, and that is 0.076. So the molarity is 0.076 molar sodium hydroxide solution. Okay, so that's a pretty typical basic problem. All right, let's try a different one here. All right, so let's say we have 2.2 moles of solute added to 345 milliliters of water. Sorry, I get the light again. Okay, 345 milliliters of water. What's the molarity? All right, so one little kind of red flag here. This is milliliters, so I need to get that to liters first. So remember, milliliters to liters, you move the decimal point 3 to the left. That's the same thing as dividing by 1,000, but that's just a faster way to do that. So 345 milliliters would be 0.345 liters. Okay, so let's plug in to our triangle equation. We're looking for molarity. We have 2.2 moles of our solute, and here we determine that we have 0.345 liters of water. Okay, moles over liters, that means we're going to divide. So we're going to do 2.2 divided by 0.345, and we get the molarity to be 6.38, we'll say, molar. Okay. All right. Let's try another one here. 3.2 molar contains 1.2 moles. And what's the volume? Okay. So this one, we're solving for volume. We're solving for liters. They gave us moles, 1.2 mole, and they gave us the molarity. So kind of like what we did before, just solving for a different variable. We are going to divide 1.2 over 3.2. So 1.2 divided by 3.2, you get 0.375, and we're solving for volume, which is liters. Okay. All right. This one, they gave you liters, they gave you molarity, and they're asking for moles. Okay, so 9.5 liters, 1.9 molar. We're solving for moles. They are next to each other, so that means we're going to multiply them. So 1.9 times 9.5, and you get 18, we'll say 0.1 mole of your solute. Okay, number 5 is a little different. Number 5, they gave you grams, the volume liters, and they're asking for the molarity. Okay. So, in the triangle, I don't have the unit grams, right? It's moles, molarity, liters, so I can't put that gram number in yet, but we'll see what we're going to do with that. We can plug in the 6.8 liters, and we're going to figure out the molarity. Okay. So what we're going to do with that grams is that we're going to convert that to moles and put it into the triangle equation. So 34.6 grams of aluminum chloride, AlCl3, handy dandy T-chart. We're going to figure out the molar mass of aluminum chloride, and we know that'll be equal to 1 mole of it. Okay, to do the molar mass, this is where you take a compound and split it up into its elements. So we have aluminum, we have chlorine, we've got 1 aluminum, we've got 3 chlorines. This is where I need the periodic table. Aluminum's mass is 27, chlorine is 35. 27, 35, that's 27. 3 times 35 is 105. So if you add those together, you get 132, and that goes right here. Okay, so grams cancels out grams, we'll be left in moles. So we're going to do 34.6 divided by 132. So we get 0.262 mole. So that's not our end answer. That is what's going to go into our triangle equation. So now we have our equation set up. We can figure out molarity now. We are going to divide 0.626 divided by 6.8 because they're on top of each other. So 0.262 divided by 6.8. So your molarity is 0.039 molar Cl3. Okay.